we have looked at negative externalities, but now we need to look at the policy, or rather policies, that can be used to correct these negative externalities. So this is the externality graph that we just drew, and the solution that I'm going to show you now is what is called in your notes as a Pigouvian tax. So this is a form of taxation, but it is not the same as the specific tax or the indirect tax that you have studied in chapter 2 on demand and supply, but rather in this case, instead of being levied on a producer of a good, it can be levied on both a producer and a consumer. So you remember I said earlier that negative externalities can include negative externalities of production as well as negative externalities of consumption. So depending on whether this graph, whether this difference here between QS and QM refers to an overproduction or overconsumption, then naturally in order to correct this overproduction slash overconsumption, we are going to need to levy the tax on either the producer or the consumer respectively. Okay, so it depends on what is the root problem that you're trying to solve. So this is our externality graph, and just a quick recap that at this point, the reason why I have allocative inefficiency, the reason why I have this overconsumption, is because my rational producers and consumers are choosing to produce or consume at this point here, where my MPC intersects MPB, and therefore I get QM. But I want to achieve my socially optimal quantity here, QS. So you cannot change the rationality of a producer and consumer. You cannot demand that they be less selfish. You cannot demand that a profit maximizing producer or a utility maximizing consumer suddenly disregard his objective as an economic agent and start to care about the external cost to society. But what you can do, sorry about that, what you can do is you can actually shift the marginal private cost associated with production or consumption such that this rational producer or consumer, after weighing his private costs and benefits, will choose to produce or consume at QS. So what is going to happen, right, is initially I have this MPC, right? So I'm going to draw a line that is parallel to MPC. So right now my MPC is where my ruler is here. I'm going to shift my ruler, parallel shift, okay, parallel shift upwards to this point here. And I'm going to draw my new MPC. So I'm going to label this MPC prime. And what do you notice? My producer or consumer is still rational, right? He is still selfish. He will still only consider his marginal private costs and marginal private benefits. But then, right, now that my MPC has been shifted upwards to MPC prime, where is the point where my MPC equals to MPB? It is now this point here, right? This green line intersects the downward sloping line at this point. And this point, which is now the new free market equilibrium, will therefore correspond to the socially optimal quantity QS. Now, to what extent do you need to shift this? If you notice here, I have shifted vertically, right? But the vertical distance that I have shifted is this part over here. So this part is equals to the MEC at the socially optimal quantity, QS. So just by looking at this graph alone, based on how I've explained it, you can see that the point of a tax, ultimately of a Pigouvian tax, is because I levy the tax, I increase the monetary cost associated. And MPC includes both explicit costs in terms of monetary costs, as well as implicit costs in terms of op costs. So by changing the explicit cost, I have increased MPC, MPC shifts upwards. But what is the limitation of a Pigouvian tax, therefore? Have you spotted it yet? The limitation of a Pigouvian tax, which is the one that they will ask you to write in exams, is that can you actually quantify for me what is the extent of this MEC at QS? Obviously not, right? So the limitation is the difficulty of estimating the monetary value of MEC, the external cost to third parties, at the socially efficient output. And this is especially prevalent in cases where you have like environmental externalities. So some notes, I forgot what the phrasing in HCI notes is, but some notes and some slides will say that because governments or regulatory bodies actually have imperfect information on the full extent of these costs and benefits, And that is why they cannot tell you, for example, if my MEC is in terms of pollution, can I really fully account for the full extent of environmental pollution and therefore say, oh, so the environmental pollution caused by this factory is worth exactly how many $1 million? Obviously, I do not have enough perfect information to quantify that amount, and therefore, if I estimate this wrongly, I can undertax or overtax. So if I estimate this wrongly, I only shift it up by a bit to, let's say, somewhere like that, right? Let me use another color. To somewhere like that, right? Then you will see that there is still a deadweight loss. There's still a small deadweight loss here. Okay. On the other hand, if I overestimate my value and I overtax, so I shift MPC all the way up to maybe here, then now then now I've overtaxed, right? So if I've overtaxed, where's my deadweight loss? My deadweight loss is now, I'm going to extend this down to here. Sorry for the rough drawing. And then remember, my deadweight loss triangle always points towards the optimal output here. So this will be my deadweight loss. Either way, you can see that in the case of both undertaxation and overtaxation, there will still be allocative inefficiency in the market. And in some cases, if the extent of under or overtaxation is too severe, the deadweight loss that results from this can actually be bigger than the original deadweight loss, which is this shaded triangle, as we examined earlier. Okay, so that's the limitation for describing a Pigouvian tax, and I hope you're more clear on how to draw the diagram now.